Recording in progress.
I'm doing great. I think this is one a very important conversation we all need to have. Thank you so much, Degan, for joining us. I'm excited to hear more about what you've built.
Hey, yeah, thanks. Thanks so much for having me on. Appreciate the time to speak about this sort of thing. Yeah, it was London. It must have been London. Yeah, yeah.
Good morning, everyone. Yeah, Degan, one of the people, and I think this is indicative of the entire BSV space. There's someone that they take time out of their day to really break things down for lay people like myself. I've been involved in technology, but I'm not, an expert by any means in any of this stuff. And we're within BSV, within Bitcoin itself, we have a very nuanced and perspective about it. So that requires understanding, why big blocks, why SPV. We can use them as sort of like banners and we can wave them, but to really build this movement into what it needs to become, a liberating movement, we need to also understand the whys. And I found Degan right away back from the days when he had created Baymail, which was before anything else, and it was a way to assign proof of work or payments to emails that you were receiving, so that you could theoretically, I want to get in Joe Rogan's inbox, so he gets flooded, but with a million people that want to get into his inbox. But if I could assign proof of work using, at the time he was using BoostPal with Daniel Krawitz, or some payments, maybe I send him $100, that's going to move my email to the top of his list. So from back in those days, probably 4 or 5 years ago, when he was creating that framework, he would just take time out of his day to answer my very, very basic questions. And ever since then, he's always just been so generous with his time. He's such a great educator, and he's someone that truly believes in the free market vision that Bitcoin brings with micropayments and data services to the whole world. So we're very, very thankful and lucky to have Degan here on the show with us today.
Wow, thanks, man. Appreciate those kind words. Hey, yeah, that's a great question. I guess My focus just now is more on BRC 100 wallet interface. And I think the paper wallet application that you're referring to is really, for me, more of a chance to see how you could integrate paper wallets into that framework. So the idea being that there should be, so my focus at the moment is building bridges between all of the various different ways that you can interact with BSV to this BRC 100 interface. So most people know that as like the MetaNet desktop application. So that's the open source implementation of a BRC 100 wallet. And building apps for that is what I'm sort of focused on just now, just demonstrating how you can use this technology. And I felt like paper wallets hadn't been talked about for years. So why not build an implementation that is compatible with the latest and greatest sort of MetaNet wallet stack? So that was really my purpose. But it's certainly an interesting topic. And securing keys has always been a difficult task. For years at the BSVA, we had been talking about things like hardware wallets, working on some of the open source libraries for things like YubiKeys, seeing if we could get the HSMs that banks use to secure funds in the BSV ecosystem, that sort of thing. And so the implementation of this app, which you can find at secure.atx.systems, is all about using the SDK's Shamir secret sharing scheme key splitting functionality. So really, this had been in the SDK for probably a year now, but no one's really used it. So I thought probably needs an implementation. So why not build it out into an app so we can kind of demonstrate how you can use this tech. Yeah. Yeah, so I mean, this is something that was born out of Babbage's early work on this stuff, but really is through conversations with me. Ty and I have been speaking for years about this stuff. Well, Ty's been trying to convince me of this stuff for years, and maybe a year ago now, or almost 2 years ago now, I sort of started to understand what he was on about and realizing, oh, this is actually exactly aligned with my mission at the BSVA, which from the get-go was SPV, and really just getting people to build out the tools necessary so that we can, at the edge of the network, scale things out. Because all of the focus had been on the center of the network. How do you get more transaction throughput? And so they needed a guy to take care of, well, what do applications need to do differently if they're not relying on these central services? So that was my mission. And it aligned really nicely with what Atai was doing. And he was one of the only guys in the ecosystem that really, I feel like, really got SPV in terms of the application development side of things and had some fantastic ideas, him and his team. So yeah, we've been working together since that point, and him and his team have been working with the BSVA to deliver this distributed application stack, which is going really well. Well, when you say Babbage stack, that's, I mean, that is the BSV stack, essentially, is what we're talking about. Babbage is, of course, prolific in the ecosystem. They're the developers that we hire to get this stuff done. But yeah, the effort is completely aligned with what the BSVA are doing. Yeah, we're effectively paying to have it open sourced, and contributing ourselves in some capacities. Yeah, I mean, that's always a challenge, right? So the more sort of obscurely secure things are, the more sort of complex the learning curve, perhaps. But yeah, I think part of my challenge has been trying to explain SPV and how that relates to security is um, even the app I built here is really for generating one key. So you generate and split one single key. And usually in most users' minds, that means there's a Bitcoin address associated with that key, and you can pay money into that, and later you can retrieve it using the private key, right? Address-based payments, in other words. So the difficulty in sort of migrating away from that concept is, although you get some benefits like avoiding key reuse is definitely something I'd advocate for. Um, if you avoid key reuse, then you need to have some other abstraction that you use to sort of define payments between people. So in the case of the BRC 100 stuff, that we do that through public keys, and we can derive lots of different addresses in some sense from just two public keys and some extra information. So like you and I could both sort of identify ourselves by a particular public key where we have the private key. And from there, we can generate a bunch of different keys for a bunch of different use cases just by kind of combining those keys with some private information between you and I. And then we can make a, yeah. Yeah, exactly. So we just call that a key derivation scheme. And so the one that we have baked into the BRC 100 spec allows you to sort of create an arbitrarily large number of keys just from a root key. So each of us have a root key, and we can kind of communicate with each other to figure out a bunch of keys that external parties would have absolutely zero chance of guessing. But both you and I know which keys are ours and which keys are yours, and so on. So that one's definitely difficult to keep sort of at layman levels. But if you don't mind dipping into the math, it's so it uses elliptic curve cryptography. Well, no, not really cryptography, but elliptic curve mathematics. There's this property of elliptic curves that allows you to sort of share public information with one another and then both calculate the same shared secret. That's commonly referred to as elliptic curve Diffie-Hellman key exchange. So you can kind of Google that or ask an AI, and it will explain that to you at any level you want, I suppose. Once you have that shared secret, you can then use that in a sort of hash function, which allows you to add some extra information before hashing. And if you both have that private information and you can both calculate a shared secret, it's a super secure way to then generate a bunch of random numbers. And really, keys are just random numbers. So you can generate lots of random numbers. And if you want to then create a key that you both can calculate the public key, but only one of you can calculate the private key, then all you need to do is add one of these random numbers to either my private key or your private key. And the other side of that equation is something called point addition. And so we can both calculate the public key associated with a hash that we've just calculated through all that math. And we add that to your public key if we want to derive a key that only you could unlock. And we add it to my public key if we want to derive a key that only I can unlock. So that's how we sort of come to an agreement about which key we're going to make payments to or encrypt things to, and so on. So hopefully that's a reasonable enough explanation without going too deep. But I'm not trying to gloss over it or anything. That really is what happens under the hood. Oh, like As a user, yeah, you don't. I mean, it's just interesting as a user. I would say you don't actually need to do anything specific yourself, other than using the BRC 100 flavor wallets. So at the moment, there's just one, but in future there could be any number. And all of this tech is vendor neutral, which means yes, Babbage are running a production stack at the moment. And any other company that's interested can run the open source software and become another provider. So if you're using MetaNet Desktop and you want to make a payment using the key derivation scheme I was describing, really you can use any of the apps on the app catalog of MetaNet Desktop. All of those will be using that or similar key derivation schemes to secure these micropayments. Yeah. Yeah, exactly. Yeah, and the one thing that I think people have found confusing about MetaNet Desktop is that it doesn't actually make payments on its own. It's not like Handcash. It's not like Centbee. It's not like anything else you've seen really. It's very specifically an architecture that separates out concerns between wallets, which derive keys and help you manage your identity, and applications, one application of which would be just making payments to other people. So it's intentionally splitting that functionality out. And this is not my idea. This is Ty's idea. Credit where credit's due. But I think it's a really good idea because what it allows is innovation in multiple fields and separately. So now we have an ecosystem where if you're really good at UX design and web applications, you don't have to worry about all that complex cryptography. You can just use the kind of standard, but you can innovate in terms of making the user experience of creating peer-to-peer payments between people smoother somehow. So if you're just great at designing cool looking web interfaces, then you can apply that and you can charge for the service of using your payments web app, and you can make money. And you can make micropayments, which means that you can make money where the lowest rung on the ladder is extremely low because the barrier to entry is basically zero, because everyone in this ecosystem can just click one button on your web app and they're immediately paying you for your service.
Hey guys, can you hear me? I don't know if I'm audible. I'm actually joining the Twitter space from my desktop computer.
We can hear you.
Cool. Yeah, happy to answer any questions about that. Dagan, I think you gave a great explanation of the way that the shared secret system works in an accessible way that the average person can understand. So that's really valuable, and I think that that's the best that anybody could really do with trying to explain some of the really complex math involved to just average people who want to use the wallet. And there's a lot of new stuff coming out, of course, with the MetaNet Desktop and some of these apps that use this. But really, yeah, separation of concerns will allow us to focus on getting each one of these little experiences right, so that at the end, when we try to have users go through the combined experience of using all of these things together to to get value from the BSC blockchain and the MetaNet stack, right? That's kind of the goal, right? Is that the combined experience would be better because everybody can focus in on each little piece. And key derivation happens under the hood. But yeah, securing wallets with those keys is something that is extremely important, and we want to make sure that as many people who can understand that stuff have the opportunity, and just be transparent about how it works, and ask answer questions from anybody, so that people can feel like their funds are secure, and that the wallet does what it needs to and protects privacy, and just of course all the code's open and everything, but not everybody can read all of the code. So we need some way to translate some of that into language that the average person can understand. And I think that's an important thing that you're calling forward to space, Gavin. So thanks for putting it on. Thanks for having us here today.
Yeah, I just had a question for Dagan and Ty. Either one of you could take this, but just to an analogy for that portion that you described, where the functionality of the wallet, of the transaction signing, etc., is sort of separated. Is an analogy for that sort of like, a personal computer when those became popular? One of the things, the advantages of a personal computer is that it's able to perform these logic functions but we don't need to instruct our computer to how to perform all these logic functions, even though we could, but we instead, use an operating system. And then, the person that's coming along, they just need to develop an app. They don't need to tell the computer how to perform all these low level functions. So it's a little bit like that, where the MetaNet desktop in a way is sort of like the operating system for the Web3 universe. And then the developers who want to come in, they don't need to go down to the low level and the primitives, etc., and they can just build off of the stack that you've provided them.
I would say, yeah, that's accurate, because actually, just to give a little bit of history and context on where we started with this. When I was 25 years ago, I wrote a paper called Computing with Integrity, and that was the foundation for a lot of stuff that has eventually evolved into this stack and this ecosystem. And internally within the Babbage team, before everything was public and open source, and before we really released a lot of this stuff for everybody to check out, we had an internal name for the what we called the CWI kernel. So CWI being Computing with Integrity kernel, and we would just call it the kernel. And an operating system has a kernel, and it was like this core thing that all of the apps would call into, and it was the driver of the wallet system, the key storage and management system, the permissioning system, and the identity system, so that all of the apps could focus on application layer stuff. And that aligns very well. So it speaks to your insight, Brett, that you could think to draw that parallel, because that's the exact same parallel that we drew internally when we would call the CWI core, or the brains of the MetaNet desktop application. We called it the kernel for that exact reason. So spot on. In the same way, I guess that as well, maybe just like you don't have to fully understand how to architect the best engine block in order to drive a vehicle down the road. The same thing applies here, where how to architect the best key derivation scheme in order to make sure that users can be in control of their stuff. Now, that's very important. In the same way, it's very important that your car does not, blow up when you're driving it. But we need to make sure that, just like with cars, right, we have good standards, good, security practices, audits, all of that type of thing. And that's one of the key reasons as well why it's so important to open source a lot of these capabilities and subject them to as many eyeballs worth of scrutiny as we possibly can. And so app developers will call down into this this wallet system, which is probably going to be part of operating systems like Mac OS, Windows, and Linux. That would be the goal anyways into the future, and also on mobile with our phones, right? But this is the interface, right, between the app and the wallet, where the wallet in some way kind of acts like an operating system, and then people can learn the way to the programming interface, the application programming interface, useful to create things on top. And that's what that we then get into BRC 100, and that's exactly what that is. It defines that layer of interoperability, and it does all of that. But I don't want to get ahead of the conversation here with that stuff. But that's certainly a key part of how this works and how it kind of separates those concerns, so that every application doesn't need to focus on key security and making sure all of the math is correct. Just like every driver on the road doesn't need to focus on making sure their engine block is designed properly in order to get where they're going.
Yeah, that makes me feel really good that I got that analogy right. I'm going to try and push my luck and maybe make one more analogy. So then going back a little bit to how Dagan described the key derivation and the ability to create this shared secret. And, one of the things that makes me think of is that in a way, then the UTXOs that are being generated sort of function a little bit like memory, because, if you just think of a squirrel, for example, when they have an abundance of acorns, they want to hide them so that they can find them in the winter, right? So they go around to the various different places in the park. Maybe they hide a couple here and they hide a couple there. In a way, this is sort of like, the operating system, when it wants to record some information that maybe it can recall later, it knows where on the disk space it's going to write that information. So, sort of like a squirrel, it goes and hides it behind the big pine tree in the park or something, and so it sounds a little bit like this shared interoperability system that you're developing and you're designing is almost using the UTXO model as like a shared memory system, where now these various different participants in that network, they can combine to store some information. So maybe we store information about my whatever it is, the application, maybe it's a gaming application, and I want to store some information about my current rank or my current score or something like that. We can combine to store that information in a location that on the disk, the UTXO set, that only myself and the gaming provider know where that is, so we both have access to it. Would you say that that's also an analogy that fits in terms of the UTXO set as sort of a shared memory bank?
I would say yes. I mean, certainly there's a lot to unpack with the UTXO sets and the way that data is tracked and managed inside of applications. But at a high level, yes, 100% accurate. That's a very apt analogy for something like output baskets, where you can put data in a UTXO, and then you can have that in a basket. And a basket is basically just a specific location where data is stored, and it sort of allows for people to we'll pull it out when it's necessary. And because that's tracked and managed by the wallet, right, it's done with user permission, so that users are able to protect the privacy of their data and give consent for any application to kind of see which particular UTXOs are stored in a particular basket within the wallet, right? And so by doing things that way, it allows us to essentially create a system where data can be portable across applications as well, right? So for example, in a healthcare application, somebody could create some data, and then maybe somebody has a different app that they've built that has a better user experience for viewing that health information. And so the second application could plug into that same basket controlled by that user within their wallet and actually access the UTXO. And then again, with user permission, it could represent it by decrypting it and then displaying it. And the data itself is held by the user in that way, and then it's just the apps plug into it. And so UTXOs are a way to record data, but also I would say they can convey value, they can convey obligation, they can convey rights, and the way they do that is by having a script. And the script can be a smart contract, it can be anything, and it can have a number of satoshis in it, right? Because for those unaware, a UTXO is really just a particular script in Bitcoin that has a particular amount of Satoshis, and then whoever fulfills the obligations of that script can, spend it. So if that script contains some data and you want to update it, well, then what you can do is you can spend the old one and you can create a transaction that has an output that replaces it. And then suddenly you've changed what that data is. You've also left history. And so by defining this chain of spends, for example, when we think about data UTXOs, we can describe the series of updates that have happened with that data over time. And so it's almost a memory bank in 2 dimensions, because you can think about, well, this is the sequence of updates that have happened to this particular data point. And this is proven on the blockchain and recorded with the history of a particular UTXO. But then also different types of data, different data points, each one in a different basket where any app can plug into it with user consent, but they're all separate UTXOs. And so they store different things. And so those 2 models, those 2 mental models, I would say, are useful for understanding the way that UTXOs work and the interplay they have for the average developer within the system. And then everything else is really just related to, okay, we're dealing with UTXOs now, right? The UTXOs represent the data, they represent the obligations, the digital assets, the things which we own or interact with, or maybe even we share ownership of a particular token with somebody else, and multiple people could come along to update it or something. But all of the other stuff is just a wrapper around that, because in Bitcoin, tokens can represent anything. And the BRC 100 standard just allows that world of tokens to be opened up and leveraged by developers no matter what they're doing. And it puts the user in control of all of this stuff associated with the tokens that they hold in their baskets, in their wallet, so that only applications with the right consent can actually access them.
Yeah, understood. Really great explanation, and I love the way that you sort of narrowed in on that specific use case, like the health data. I have a couple follow-up questions. One question, this is sort of a question for Dagan. This is a question about, okay, so first of all, I understand why you fit so nicely with Ty. It's like the left hand and the right hand. Because everything that Ty is describing is completely in line with your vision of SPV, of high data volume, open data services, interoperability, and creating that competitive market, like Ty was saying, where if someone can come along and provide a better user experience, there shouldn't need to be that vendor lock-in. And I can understand why it's so important to Ty too, because it restores that integrity of the information to the user themselves. But the question I want to get to with Dagan is basically, how do you begin to create a library or SDK or a framework when you know that you want to accomplish something that is so, such a grand vision, and then you say, okay, well, we know we want to achieve that, but we actually have to build the open source libraries that can reach that. Do you have to work backwards from the vision? How did you go about sort of prioritizing what needed to be included in the open source libraries that allow for this vision to be achieved?
Well, I mean, multiple attempts is the first answer that comes to mind. So it's not like I had some specific grand vision and I was always in charge of exactly what happened. That's not how it worked. I was at first just a dev at nChain for a very short period of time, just a couple of months. Sort of joining the team to work on code that was going to implement SPV for a payD at the time, and I think back then it was called the SPV tool, or the wallet toolbox. I don't know. I'm getting confused about all the names. Light Client Toolbox. That's what it was called. So that was kind of the first attempt that I was involved in to trying to sort of real world implement something where you could pass a transaction between 2 users, and the receiving party could completely validate the transaction that was being handed to them using Merkle paths and all of that sort of thing. And I was just one of the devs that was working on that. And a couple of devs before me had built the foundational sort of Go BT, BK, BC, those Go libraries that I was working with to try and bring those tools to fruition. And at the time, I was working with the TSC on trying to standardize the way. Actually, that's where I met Ty, I suspect. Trying to standardize the way these payments work. So, what was the payment process? What was the flow of information between the counterparties? How could we make that sort of stable so that everyone knew what to do while keeping it flexible so that we could have innovation and allow for that? So, that was all a sort of balancing act. And then, having to make up formats for things because they didn't exist yet, or the ones that did exist weren't adequate, was the start of, talking with Ty a little bit more in terms of how things could be done. I think by that point, Ty probably had some of that initial sort of eureka moments and building his own stack with his team in his own direction, and that was quite different at the time. Maybe just in flavor, same direction, just a different flavor. And a couple of the libraries in the ecosystem were starting to go stale at that point. Ryan X. Charles was involved with the Money Button libraries, and that was the kind of go-to library that Scrypt and Babbage's stack were built on. And around that time, I was kind of moving across the BSVA and moving up the ranks there, trying to help get this SPV stuff working. And I kind of realized at that point the base library that everything was built on was very well, it was just built by people who understood Bitcoin slightly differently than I do, and it was missing the functionality that you need to handle SPV, to validate transactions yourself. And it was entirely built around the address-based payment model. It would have functions in there. Well, I don't need to get into that kind of detail, but really the address-based payments was the foundation of that whole library. And so I thought, well, how are we supposed to encourage developers in the ecosystem to build their applications in this way when the fundamental building block, the sort of SDK that they based their app on, wasn't capable of doing that stuff, or didn't have it built in, and certainly was sort of awkward and cumbersome to get that sort of thing working. So fair enough to Ty and team. They did manage to get something working, and it was very much a moving target. In that, at the time, Mappy was the way that things were being broadcasted. There was get Merkle proof JSON RPC to an SB node. Then there was get Merkle proof 2, which was a TSC Merkle proof standard. And since we've moved on to Bumps, which is an attempt to unify into a single format. So a BSV unified Merkle path format. That's why it's Bump. But I mean, I suppose long story short, it was through realizing that you had to start from the ground up to change the way in which libraries in general. I mean, I'm no computer scientist. I really worked my way across into this industry from elsewhere. But my understanding now, and partly influenced by Siggy, who I see is listening, trying to remember what he's told me in the past, because I've learned tremendously from him. The libraries are really just a way to help the developer think about things. That's really what they're doing. So if you have certain language in the libraries that is in favor of SPV because the way the transaction is constructed relies on a previous transaction and its Merkle path, then you're giving the developer the sort of mental model they need to understand how to build applications that rely on that technique. And that just didn't exist before. So, of course, the obvious partner to work with to develop these libraries was Ty and team, because they had, I would say they had gotten closest to how I imagined it would work. So, I mean, it just made sense to work with them because they were really in the same mindset as me, and they had the same values and the same understanding of why it was important. And then after doing that initial SDK with them, I realized that, well, actually, a lot of their tooling that they'd built around their sort of extended version of the old money button library was close enough to what I was looking for that it would be silly to rebuild that stuff in my own flavor. And it made a lot more sense to just partner with them and start advocating for what they had already figured out. And so really credits to Ty for figuring it out from nothing. And I guess my part in it was identifying that they had got it right. And I wanted to join that bandwagon and support it as much as I could in my capacity at the BSVA. Right. I'd love to ask the AIs about some of Brett's analogies. I think that would be hilarious because they're so salient. But really, usually, no one else could think of them. It's brilliant. HTTP. It's the language that the markup language that everyone's speaking on the web, I suppose. And I guess the analogy fits because, if everyone's speaking BRC language, then they're all going to be compatible. And we've found with HTTP, there's loads of different frameworks that all work in their own languages, yet they spit out HTTP because that's the universal. So I can see why that's an apt observation, and certainly something to aspire to. If we can get BRC 100 as ubiquitous as HTTP, then we will all be in very comfy chairs, put it that way.
One more question, just on the topic of the compute with integrity and the open source libraries with that Dagan was talking about. The question is just about how important on a scale of 1 to 10 is Pushdrop to that vision of computing with integrity. And then can you describe and explain Pushdrop for the average person? Maybe this is a question for Ty. And how does it fit in with that overall vision?
Yeah, I want to answer before Ty jumps in and maybe fills in some of the background of the design decisions around Pushdrop. I guess from my perspective, when I saw Pushdrop, I was like, yeah, that's actually what I've been calling it too, because that's what you do. You push